What if everything you've ever known about reality is just one version of the truth? For centuries, humanity has stared into the night sky and wondered, is this really all there is? Are we confined to a single universe? Or are we just one bubble in a vast, infinite sea of worlds beyond imagination? Some of the brightest minds in history have wrestled with this question. Philosophers tried to reason it out. Scientists searched for clues in the deepest corners of space. And yet, the more we uncover, the stranger the picture becomes. Because the real question isn't just whether other universes exist. It's whether those universes might be different. Universes where the laws of physics twist in alien ways. Universes where countless versions of you are living out completely different lives. Universes where the impossible is reality. And the deeper we go into this mystery, the more unsettling the possibilities become. But to understand how we even got here, we need to start with the simplest idea of all, that the universe we live in might not have an edge at all. At first glance, our universe feels enormous. The galaxies, the stars, the billions of light years we can barely glimpse with our most powerful telescopes, it all seems impossibly vast. But here's the twist. What we see is only a tiny fraction of the whole picture. Astronomers call it the observable universe. That's the region of space where light has had time to reach us since the Big Bang, about 13.8 billion years ago. Beyond that, we simply can't see, not because nothing exists, but because light hasn't had enough time to get here. Now imagine if space doesn't stop where our vision ends. Imagine it just keeps going, endlessly, in all directions. That's the first and most straightforward kind of multiverse. The Level 1 multiverse, as physicist Max Tegmark describes it. An infinite universe, stretching forever. And here's the strange consequence of infinity. In an endless cosmos, every possible arrangement of matter will happen not just once, but an infinite number of times. That means somewhere out there, far beyond our cosmic horizon, there could be another Earth, another solar system, another version of you, living a life that might look uncannily familiar or shockingly different. It's like walking into a casino with an infinite number of slot machines. Eventually, every possible combination appears, not just the jackpot, but every outcome you could imagine. Infinity guarantees repetition. So when we look into the sky, the stars may not just be scattered points of light. They may be the closest hints of countless realities that mirror our own. But if infinity itself isn't enough to blow your mind, scientists believe there's an even stranger possibility. What if the universe doesn't just extend forever? What if new universes are constantly being born? To understand the next step in the multiverse, we have to go way back to the very first moments after the Big Bang. According to a theory proposed by physicist Alan Guth, the universe didn't simply expand slowly over billions of years. In its earliest fractions of a second, it exploded outward at a speed faster than light. This idea is called cosmic inflation, and it explains why our universe looks so smooth and uniform today. Without it, galaxies and clusters would be scattered in strange, uneven clumps. But here's where it gets weird. Inflation may not have been a one-time event. Many cosmologists now believe it's eternal. That means while our region of space stopped inflating and cooled into galaxies and stars, other regions kept expanding forever. And inside that runaway expansion, countless new universes like little soap bubbles are constantly forming. Each bubble is its own universe, sealed off from the others by ever-expanding space. And here's the kicker. The physical laws inside those universes may not be the same as ours. In one bubble, gravity might be far stronger. In another, atoms may never form. Some bubbles could be completely sterile, while others might give rise to civilizations more advanced than anything we can imagine. Think of it like a cosmic lottery. Every time a new bubble forms, it rolls the dice on a new set of rules. We just happen to land in a bubble where life could emerge. And this raises a haunting thought. If universes are being created all the time, then reality is far bigger and stranger than our minds can even process. Our cosmos might just be one tiny bubble in an endless, frothing sea. But even that might not be the end of the story, because some scientists believe the universe doesn't just inflate forever. It might actually recycle itself in ways we can barely comprehend. When most of us imagine the universe, we think of a single beginning, the Big Bang, and a single ending, somewhere far in the future. But what if that's not the case? What if the universe doesn't just begin and end, but instead repeats over and over again in an endless cycle? This idea isn't new. In fact, it dates back nearly a century. Russian physicist Alexander Friedman first suggested that instead of expanding forever, the universe might one day slow down, collapse in on itself, and trigger a new Big Bang, starting the whole process again. This is sometimes called the oscillating universe model, where each cycle gives birth to the next. It's a fascinating picture. Universes being reborn like cosmic phoenixes, each one rising from the ashes of the last. But there's a problem. With each cycle, entropy, the measure of disorder, should increase. That would mean every new universe is more chaotic than the one before it, eventually collapsing into complete disorder with no chance of starting over. But then came Roger Penrose, one of the most brilliant minds in modern physics. Penrose introduced a radical twist known as conformal cyclic cosmology. In his vision, the universe doesn't reset in the traditional sense. Instead, the far future of one universe, after all the stars have burned out and only radiation remains, becomes mathematically indistinguishable from the very beginning of the next. In other words, universes don't restart in a messy collapse. They flow smoothly into each other, like overlapping chapters in an infinite book. If Penrose is right, then our Big Bang might not have been the first. It could have been just one moment in an eternal chain of cosmic aeons, each one giving rise to the next. And here's the chilling part. Penrose claims to have found evidence for this. He and his collaborators argue that faint patterns in the cosmic microwave background, the afterglow of the Big Bang, may actually be echoes from a universe that came before ours. If true, that would mean we're not living in Universe 1. We're just the latest link in an infinite chain of realities stretching endlessly into the past. But what if the universe isn't reborn from cycles at all? What if new universes are created inside some of the most mysterious objects we know of, black holes? Black holes are some of the strangest objects in the universe. They form when massive stars collapse under their own gravity, creating regions so dense that nothing, not even light, can escape. To us, they look like bottomless pits in space. But to some physicists, they may be far more than that. Theoretical physicist Lee Smolin put forward a radical idea called the Fecund universe hypothesis. Instead of thinking of black holes as cosmic dead ends, Smolin suggested they might actually be the seeds of new universes. Here's how it works. When a black hole forms, the singularity at its center may not just crush matter into oblivion. Instead, it could trigger a new Big Bang on the other side, a brand new universe branching off from our own. From our perspective, the black hole looks like a one-way trap, but inside, it might be the birthplace of another cosmos. Now here's the fascinating part. Smolin argued that each new universe might inherit slightly different laws of physics, and the universes that produce lots of black holes are more likely to create even more universes in the future. This is a kind of cosmic natural selection, where universes evolve over time, favoring the ones best at reproducing through black holes. Think about what that means. The reason our universe has stars, galaxies, and even life may not be a coincidence. It may be because these conditions also happen to produce black holes, which in turn give rise to new universes. In other words, we may exist not because of chance, but because our universe is part of a much larger process of cosmic evolution. Some scientists have even speculated that our universe could be the interior of a black hole from another, larger universe. If that's true, then every black hole we see in the night sky might be a doorway to another reality. It's a wild, almost science fiction idea. But it raises an even bigger question. What if universes don't just branch off from black holes, but are built into the very fabric of higher dimensions. To understand the next vision of the multiverse, we have to dive into one of the most ambitious theories in modern physics: string theory. String theory proposes that everything in the universe, every particle, every force, every bit of matter and energy, is made up of unimaginably tiny, vibrating strings. These strings aren't like anything we can see. They exist on scales far smaller than atoms, and their vibrations determine what kind of particle they appear as. But here's the catch. For string theory to work, the universe can't just have the 3 dimensions of space we're familiar with. It needs extra dimensions, 6 or 7 hidden ones, curled up so tightly that we don't notice them in daily life. And this is where things get mind-bending. Those hidden dimensions can be folded, twisted, and shaped in countless different ways. Each unique shape leads to a different set of physical laws, a different kind of universe. When physicists tried to calculate all the possible variations, the number was staggering. Not thousands, not millions, but around 10 to the power of 272,000 possible configurations. This staggering collection of possibilities is known as the string theory landscape. And within that landscape, every possible universe might exist, each with its own version of physics, chemistry, and even reality itself. One version of this idea, called the ekpyrotic model, even suggests that our universe began when 2 giant brains, enormous, higher dimensional sheets of reality collided. Imagine 2 cosmic membranes smashing together in a higher dimensional space, releasing an explosion of energy that we now call the Big Bang. If this model is true, then our universe isn't unique. It's just one brain among countless others, floating in a higher dimensional sea. And those other brains could hold universes with laws so alien that we might not even recognize them as universes at all. But string theory and higher dimensions are just one way to picture the multiverse. There's another theory, one that doesn't just involve space, but the very rules of quantum physics themselves. So far, every version of the multiverse has come from cosmology, the study of space, time, and the universe as a whole. But the strangest vision of all doesn't come from looking outward into the stars. It comes from looking inward, into the tiniest building blocks of reality. This is the world of quantum mechanics, where particles don't behave like solid objects, but instead exist in fuzzy clouds of probability. A particle can be in multiple states at once here and there, spinning one way and the other until the moment we measure it. That's when the wave function seems to collapse into a single outcome. Physicist Hugh Everett asked a dangerous question. What if the wave function never collapses at all? What if, instead of one outcome being chosen, all outcomes happen each in its own branch of reality? This idea became known as the many worlds interpretation, and it describes a quantum multiverse that is branching all the time. Every time a particle makes a quantum decision, the universe splits. Every possible event that could happen does happen, but in a different universe. That means there isn't just one version of you listening to this right now. There are countless versions, each living out different possibilities. In one branch, you clicked away from this video. In another, you're watching until the very end. And in still another, maybe you never even discovered this channel at all. It sounds impossible, but mathematically, the many worlds interpretation fits perfectly with quantum theory. In fact, it removes one of the strangest mysteries of physics, the collapse of the wave function, by saying it never collapses at all. Of course, not everyone buys it. Critics argue that the many worlds model is wasteful, creating an unimaginable number of universes just to explain one simple measurement. But supporters counter that it's no more bizarre than believing in a magical collapse that defies the equations of physics. If Everett was right, then our universe isn't just one of many bubbles or brains. It's one branch in an endlessly splitting tree of realities, a tree that grows every second, with every decision, on every scale. And yet, even this isn't the most extreme vision of the multiverse, because some physicists believe that the ultimate reality might not be physical at all, but mathematical. Up to this point, every version of the multiverse has been tied to physics, to space, time, energy, and particles. But some scientists believe the deepest truth about reality isn't physical at all. It's mathematical. Physicist Max Tegmark calls this the level 4 multiverse, the most radical version of them all. His argument is simple, yet staggering. If mathematics can describe a universe, then that universe exists, not just in theory, not just on paper, but as a real, independent reality. Think about that. Equations aren't just tools we invented to describe the world. They are the world. In this view, every consistent mathematical structure corresponds to its own universe, which means there aren't just billions of universes. There may be an infinite number of them, as many as there are ways for math itself to exist. But there's another angle to this that's just as unsettling: the simulation hypothesis. It suggests that our universe might not be the base reality at all. Instead, we could be living inside a vast simulation, created by a civilization far more advanced than ours. Think of it like this. If a civilization can run computer programs complex enough to simulate entire worlds, then what's stopping them from simulating entire universes? And if they can do it once, they can do it millions of times. In fact, some argue it's statistically more likely that we're living inside a simulation than in the one true, original reality. And here's the kicker: if that's true, the universes inside simulations might themselves create new simulations. Reality could be nested like Russian dolls, with layer upon layer of simulated worlds, each one convinced it's real. It's a dizzying thought, but whether through mathematics or simulation, this ultimate version of the multiverse suggests one thing: our universe may not be unique, or even fundamental. It might just be one possibility among an infinity of others. But with all these theories, infinite space, bubble universes, cosmic cycles, black holes, string landscapes, quantum branches, mathematical worlds, and even simulations, we're left with a haunting question. If so many possibilities exist, why do we find ourselves here, in this particular universe? From infinite space to bubble universes, from cosmic cycles to black hole offspring, from higher dimensions to quantum branching, and finally to mathematical worlds and simulations, each theory offers a glimpse into a reality far stranger than anything we experience day to day. And yet, the deeper we dive, the more one truth stands out: we still don't know. The multiverse remains one of the greatest mysteries in science. Some physicists are convinced it's real. Others dismiss it as speculation. Evidence is scarce, and proof may remain forever out of reach. But here's what makes the idea so powerful. It forces us to look at our place in the cosmos in a new way. If infinite universes exist, then somewhere out there are worlds where history unfolded differently, where you made other choices, where reality itself follows rules we can hardly imagine. And if we really are just one universe among countless others, then what we call the universe is only a tiny fragment of a much grander existence. At the same time, the multiverse offers a strangely comforting thought. Out of all the infinite possibilities, we find ourselves here in a universe where stars formed, planets coalesced, and life was able to emerge. Whether by chance, by cycles, by cosmic evolution, or by design, this universe gave us a chance to ask these questions at all. And maybe that's the real message hidden in the mystery. The multiverse might be real, or it might not. But the very fact that we can imagine it, that we can build theories reaching beyond the edge of our universe, is proof of something extraordinary. Our curiosity, our drive to seek answers, and our refusal to accept limits. Because in the end, the multiverse isn't just about other worlds. It's about us and our endless quest to understand the deepest nature of reality.